Old machines. When they were built, there was no internet, electricity wasn't widespread, and modern technology didn't exist. Yet, they are still running. For hundreds of years. They may be rusted, their paint may be peeling, but their gears are still turning. How? Today, a device we buy breaks down in just a few years. So how is it possible that some machines can survive 2 entire centuries? What made them so durable? The materials? The engineering? Or the philosophy of production at that time? Maybe machines back then weren't built just to function, but to last for generations. In this video, we're going to explore the secrets behind machines that have defeated time. If you're ready, let's begin. Number 6. Inside the Tower of St. Michael's Church in Hamburg, about 100 meters above the ground, there is a massive clock mechanism that has been running for centuries. This clock has been telling time since the 18th century. That's roughly 250 years of continuous operation. The tower features 4 separate clock faces, each measuring about 8 meters in diameter. That makes it one of the largest tower clocks in Europe. And think about this. This mechanism doesn't run on electricity. It doesn't rely on digital systems. There's no software involved. Just gears, weights, and gravity. Every single day, every single hour, metal gears touch and move against each other. That's about 8,760 hours per year. Over 250 years. That's more than 2 million hours of motion. And it's still running. It has witnessed wars. It has survived fires. The city around it has changed countless times. But the mechanism kept turning. Today, an electronic clock might last 5 or maybe 10 years. This one, it has been on duty for nearly a quarter of a millennium. So what's the secret? Higher quality materials? More precise craftsmanship? Or a time when long-lasting truly meant something? Maybe some machines aren't built just to measure time. Maybe they're built to challenge it. Number 5. The year is 1854. The Industrial Revolution is in full swing, but electricity is still not widespread. And that year, on the Isle of Man, a massive machine is built. Its name, the Laxey wheel. This wheel has a diameter of 22 meters. That's roughly the height of a 7-story building. Its weight, around 200 tons, and it rotates at just 2 to 3 revolutions per minute. It may sound slow, but with every turn, it lifts water from about 450 meters underground. That's almost the height of a skyscraper. Now think about this. If it runs 8,760 hours a year, over 170 years, this wheel has turned millions of times. No electric motor, no fuel tank, no software updates, just the power of water, iron, and gravity. Today, if a modern machine lasts 20 or 30 years, we call it successful. But this giant wheel, it has been standing for nearly a century and a half, and it's still turning. So what's the secret? Thicker iron? More patient engineering? Or a time when long-lasting truly meant something? Maybe some machines aren't built to be fast. Maybe they're built to outlast time itself. Number 4. The early 1900s. No diesel engines. No electric trains. The heart of transportation was steam. And onto the stage comes a machine, the Peckett steam locomotive. These locomotives were built in Bristol, England. In total, more than 1,800 Peckett engines were produced. Some of them are still operational today. Most of these locomotives weighed between 20 and 30 tons. Their boiler pressure averaged around 160 psi, which is roughly 11 bar. Their top speed wasn't very high, usually between 25 and 40 kilometers per hour. But speed wasn't the point. Power was. Despite their compact size, they could haul tons of cargo industrial rail lines. Hundreds of piston movements per minute. Hours of operation every single day. Thousands of kilometers traveled each year. And some of them have been standing for more than 100 years. Think about that. One machine, 1 century. They witnessed 2 world wars. They lived through the industrial era. They saw the rise of the diesel age. And yet, they're still on the rails. No software, no electronic boards, just steel, fire, water, and pressure. Today, if a vehicle lasts 15 or 20 years, we're impressed. But these machines, they crossed the century mark. So what's the secret? Thicker steel? Simpler design? Or the fact that they were built in a world where things were meant to be repaired? Maybe some machines aren't built to be fast. Maybe they're built to last. And the Packet locomotive is there, still racing against time, powered by steam. Number 3. Take a close look at the machine in front of you. This is not just an ordinary printing press. This is the Heidelberg Original Cylinder. Production began in Germany in 1914. That means some of these machines have been running for more than 100 years. Fully mechanical, built from tons of solid steel. Depending on the model, it weighs between 3 and 5 tons. No digital screen, no electronic control panel, just gears, cylinders, and precise engineering. This machine could print around 3,000 to 5,000 sheets per hour. Think about that. That's roughly 80 pages per minute. And it did this with millimeter-level precision. Its printing area could reach up to 54 by 72 centimeters. For its time, that was incredible capacity. Books, newspapers, posters, industrial labels. For years, even decades, it kept printing without stopping. And here's the most impressive part. Many of these machines are still operating today. Parts are replaced, maintenance is done, and they go back to work. Today, modern printer might last 5 to 10 years before it's discarded. But this machine, it can cross an entire century. So what's the secret? Over-engineering? Thick steel construction? Or a culture built around repairability? Maybe machines back then weren't designed to be disposable. Maybe they were built to serve generations. And the Heidelberg Original Cylinder, it didn't just print ink, it printed history. Number 3. You walk into a room, metal panels stretching along the wall, cables, orange lights glowing inside glass tubes. It's not silent. But it's nothing like today's computers either. The year is 1951. When this machine was built, even owning a television was a luxury. Its name, the Harwell Decatron. It weighs about 2.5 tons. Inside, there are roughly 800 vacuum tubes, and exactly 480 Decatron tubes. Each of those tubes displays calculations through glowing rings of light. When it performs an operation, small neon circles move inside. It's as if you can actually see the numbers. Modern computers perform billions of operations per second. This machine, maybe just a few steps per second. But speed wasn't the goal. This computer was designed for nuclear research. It needed to carry out long and complex calculations reliably. And here's the remarkable part. Nearly 75 years later can still be powered on. While modern devices are discarded after just a few years, this massive machine can still stand up and run. Because it wasn't born in an age of fragile technology, it was built in a time when durability mattered. Slow, large, heavy, but steady. The Harwell Decatron reminds us of something important. The most impressive machines aren't always the fastest ones. They're the ones that stay standing the longest. And this machine is like a light show working against time itself. Number 2. Imagine a bridge in London. It doesn't just connect to sides of a river. It opens, it closes, and it has been doing this for about 130 years. The year is 1894. When Tower Bridge first opened, it operated using a massive hydraulic system. There were no modern electric motors. At the heart of the system were 2 giant steam engines. These engines compressed water to around 750 pounds per square inch. That's roughly 100 times the pressure inside a modern car tire. That pressurized water lifted the bridge's 2 enormous bascules. Each bascule weighed about 1,000 tons. That means nearly 1,000 tons of steel were moving. And this massive structure could open in about 1 minute. Think about it. The late 19th century. No computers, no automation software, yet 2,000 tons of steel rose into the air powered only by steam. The system was designed so well that from the day it opened, it operated thousands of times without failure. Today, the bridge still opens. Modern electric systems are now used, but the original hydraulic engines are preserved in the museum section. Because this system didn't just lift a bridge, it lifted the limits of engineering. The hydraulic heart of Tower Bridge reminds us of something. The most impressive machines are sometimes invisible, but behind every movement, there are tons of force, hundreds of engineering details, and perfect balance. And more than a century later, that bridge still rises. Number 1. No wind, no sound, no guarantee of return. The year is 1977. Two small spacecraft are launched from Earth. Their names, Voyager. Each one weighs about 700 kilograms, lighter than a car. But what they carry is a message from humanity. Inside them is a gold-plated record. It's called the Golden Record. It contains greetings in 55 different languages, music from Earth, and the natural sounds of our planet. But the real story is distance. Voyager 1 is currently about 15 billion miles away from Earth. That's roughly 24 billion kilometers. Even light needs about 22 hours to travel that far, which means when we send a signal today, the reply can only arrive the next day. And it is still operating. It has been nearly 48 years. It has left the solar system. It has entered interstellar space. No human-made object this ever traveled this far. Its speed? About 38,000 miles per hour. And even at that speed, reaching the nearest star will take around 40,000 years. Think about that. Technology on Earth becomes outdated in just a few years. But Voyager has been traveling through the darkness of space for nearly half a century. It doesn't rely on solar power. It carries a nuclear power source designed to last for decades. And maybe the most incredible part about Voyager is this. It's not just an exploration probe. It's a message in a bottle. If one day another civilization finds it, it will tell them one simple thing. We were here, and right now, billions of miles from Earth. Two small machines continue their silent journey, not against time, but against infinity. Some machines don't just work, they resist time. Years pass, technology changes, but they are still on duty. Maybe it's not about speed, maybe it's about durability. If you enjoyed this video, don't forget to like it, subscribe for more stories of machines that challenge time.